Suppose you take an equilateral triangle, which is also equiangular, so I'm talking about the one on the outside here, including the dotted lines, and you draw an altitude. Then what you've done is you've created two congruent triangles side by side here. Now if it's equilateral to start with, let's call this guy out here, which is a hypotenuse, we're going to say that its length is 2a. That meant that that guy's length was 2a, and all the way across the bottom is also 2a. Okay, it's easy to prove those triangles are congruent, so it splits the bottom up into pieces that are A and A. At this point, I'm going to lose half the diagram because I really don't need it for the rest of our discussion. So I'm going to lose this left half and the 2a along the bottom. But it's good to remember where this all comes from in case you need to recreate this rule on your own. Okay. Well, the 2a is the length of our hypotenuse across from the right angle. This guy is a leg. So let's label the other one B. It will be our other leg. Now the legs in this guy, unlike the 45, 45, 90, the legs are not the same length. In a 30, 60, 90 triangle, the shorter of the two legs, the short leg, which is A, is opposite the 30-degree angle. Okay, opposite the 30, we always find the short leg. Doesn't have to be on the bottom, but it's always opposite the 30. The long leg, which would be B in this case, is opposite the 60-degree angle. The third side is the hypotenuse. We always find the hypotenuse opposite the right angle. So hypotenuse, which I have labeled in my example here, is opposite, which is my 2a, is opposite the right angle. So we have three parts to this guy. We have a short leg opposite the 30, a long leg opposite the 60, and the hypotenuse, as in any right triangle, is always opposite the right angle. Well, again, one of the relationships between sides we can see, that the hypotenuse, right up here, is twice as big as the short leg. So one of our rules for 30, 60, 90 is that the hypotenuse, HYP for hypotenuse, is the short leg multiplied by 2. Now, I'm going to use the Pythagorean theorem like we did in the 45, 45, 90, work it out to figure out the relationship between the long leg and whatever I can get it to. It's going to be to the short. So, if I do that, that would be a squared plus b squared equals 2a squared. Well, that would be a squared plus b squared equals, and when you square a product, you square both parts, so that becomes 4a squared. I'll subtract an a squared from both sides. That will give me b squared is equal to 3a squared. Well, like I did with the 45, 45, 90 problem, I'll take the square root of both sides. The square root of b squared equals the square root of 3 times a squared. That means that b will be a multiplied by the square root of 3. In terms of what these actually are, that gives me the rule that b, the long leg, is equal to the short leg multiplied by the square root of 3. Okay, let's take a look at a couple of examples that use these rules. I'm going to take and erase and rewrite my two rules up at the top here so we've got a little more room. So my two rules are hypotenuse is short times 2, and long is short times root 3. So, in our first example, let's give us the short leg and make it 7, and we're going to find x and y here. Okay, well, being given the 7, that's the short leg, is the easiest thing to be given because the other sides are based upon how long it is. So if I use the rule hypotenuse equals short times 2, then hypotenuse, that's my y, equals my short, which is the 7 times 2, y is 14. If I use the rule long equals short root 3, then long, which is across from the 60, that's my x, it is the short, which I was given, 7 times the square root of 3, and that guy's over. So being given the short leg is the absolute best. The second easiest, which I'm not going to work out here because of time on the video, is to be given the hypotenuse, and then you just merely need to know it's twice the short, so the short would be half of it. So in this case, if I knew y was 14, I could cut it in half and get the short leg, and then to find the long, I do the same thing I did here. Okay, the hardest thing to be given is the long leg, so let's do one of those examples. Okay, so in this example, I've been given the 11. The 11 is the long leg, again, because it is opposite the 60-degree angle. Okay, so I have no choice about what rule to use. The rule I have to use is long equals short root 3 because I've been given the long, and that's the only rule that involves it. So I'm going to substitute directly underneath my rule here. If long is short root 3, then 11 equals the short, which is a, times the square root of 3. Again, to solve for this, this is times, so I have to get rid of that root 3 by dividing. Here they cancel. I'm going to switch sides. So a is equal to 11 over the square root of 3. If we're not requiring you to rationalize, you're done. If we are going to rationalize, it would just mean to multiply by root 3 over root 3, and this would become 11 square root 3 over 3. To finish the problem, I would have to find c, which is the hypotenuse. I'll just use the rule hypotenuse is short times 2. It's my other rule. Well, I know short now. I just figured it out, and I want the hypotenuse. So the hypotenuse c is the short 11 square root 3 over 3 multiplied by 2. Now 2 is a fraction, is 2 over 1, and when you multiply fractions together, you multiply tops times tops, bottoms times bottoms, so c is 2 times 11, that's 22 square root 3 over 3. And that's absolutely as hard as it can get for 30, 60, 90s.